Before I jump into how RFDiffusion handles symmetry, I wanted to define these terms because I think they come up a lot and people don't know what they mean. So just to put it in very simple terms, I like to think of invariance as a property of a network where if you give it an input and maybe rotate it in any different way, it doesn't affect the output. In contrast, equivariance is sort of a complementary concept, but in this case, when you rotate the input, the output is going to also rotate equivalently. So RFDiffusion, because it's built off of Rosetta fold, which is equivariant, also turns out equivariant. So just keep that in mind. So RFDiffusion handles symmetry essentially by creating monomeric noise and then making the copies in the desired symmetry that we ask it to. And I want you all to remember this because it's going to come up in Matt's lecture later, but the symmetric copies that it creates are done around the z-axis. So after this, it implements what we call symmetric sampling, which is essentially the model, when it adds or removes noise from one monomer, it does the same across all the monomers. So that's how it keeps the assemblies symmetric. It's also interesting because this integrates with diffusion's attention mechanism really well, and the attention heads can actually look across symmetric copies. So when the model is designing one part of the interface, it's actually aware of what's happening to all the symmetric partners. And this is why it leads to the realistic interfaces between the oligomers, because it sort of understands this symmetric environment, even though it's only making changes to one at a time.